gross section is yielding and when the net section fractures, no, or ruptures, no, yung mapuputol siya. Okay, again, gross section yielding is caused by excessive deformation. Okay, tandaan nyo yan. So for some connection configurations, the tension member can fail due to tear out of material at the connected end. And this is what we call a block shear. Tama pala. So the failure of a member may occur along a path involving tension on one plane and a shear on a perpendicular plane. No? Perpendicular to the shear on the perpendicular plane. Okay, so if you look at those three figures, okay, two of which are connected by bolt and one is connected by through welding. No? Letter A and B are bolted connection and letter C is a welded connection. So what will happen? What are the possible steering failure? So we look first at figure A. So the crosshatch parts may tear out. Itong mga shaded part daw. Okay, might tear out. And what are the possible failure? Okay, failure planes. Okay, since this is the load class, ito yung load natin, ha? Okay. Yan. Of course, parallel to that line, okay, that shear plane is our shear plane. Etong part na ito. This will tear out through sliding. Excuse me. Okay. So that it is in shear. Okay. Mapuputol ito. Okay. Through this load. Okay. Ng sliding. And then what? This is in tension plane. Okay. Because alam nyo naman kung ano formula for tension and shear, di ba? Yung basic stress formula. Okay? The area being sheared for the shearing stress would be that area that will tend to slide, and for tension or compression, that would be the area that is perpendicular to the applied loading. Now, so that this part is in tension and this part is in compression. So maghihiwalay daw yan. That would be a block. Okay, na matitear out. So that's why it is called a block shear or block shear rupture. Okay. So next one is a bolted flange. So yung flange ng ating wide flange section ay nakakonect siya ng ganito. And then the possible block shear would be this one. Okay, one here, and then on the other side of the flange would be another tearing out. So again, of course, that part which is perpendicular to the applied load would be in tension. Okay, and parallel to that would be in shear. Okay, so that's the possible rupture. Okay, what about this welding connection? Siyempre kung welded ito, plus, it will be welded here, okay, sa ends, no? And then, this block, the shaded one, okay, would rupture, okay, due to this loading. And then what will happen? We also have a tension plane and a shear plane. Shear, of course, is this two. Okay, that's one, and then this is two. Okay, and this plane number 3 will be in tension because it is perpendicular to the applied load. Okay, which is the tensile load. Alright. So the failure of a member may occur along a path involving tension on one plane and shear on another plane. perpendicular. Perpendicular ang sabi. Shear that is perpendicular to the tension plane. Okay. Now, when a tensile load applied to a connection is increased, the fracture strength of the weaker plane will be approached. So, looking at, since we have tension and shear plane class, one of which would be a weaker plane, no? At ang sabi, of course, maunang mag-fail yung isang part dyan. Okay, it's either the tension or the shear plane. So that plane will not fail then. No? The fracture strength of the weaker plane will be approached. That plane will not fail then because it is restrained by the stronger one. Tama yon. No? Yung unang mag-fail will not basically fail first or hindi muna siya mag-fail because of the capacity ng isang plane. The load can then be increased until the fracture strength of the stronger plane is reached. During this time, the weaker plane is yielding. So the total strength of the connection equals the fracture strength of the stronger plane plus the yield strength of the weaker plane. Okay? Now, block shear can be thought of as being a tearing or rupture failure and not a yielding failure. Ito tandaan nyo. Okay? Block shear is a tearing or rupture failure. Okay, and it is not a yielding failure. So that our formula is something like this. Can you guys hear me? Hello, camera. Okay. It is a rupture class. That's why the factor of safety and the reduction factor, okay, for LRSD and AST are the same with our limiting state number 2, which is net area rupture. We also use Phi to be 0.75 and omega for our factor of safety, omega for AST, no, as 2.00. Now, what is our formula? Our block shear strength, nominal, no, because it is Rn, R sub n, is equal to 0.6 FU ANV plus UBS FU ANT. N should be less than or equal to 0.6 FYAGV plus UBS FUANT. O, diba? Ang ganda. So, bakit may less than or equal, sir? You have to, tawag na ito, evaluate them. Dalawa sila, no? If, in case, this is larger, you have to use this as your R sub n. Okay? Itong part na ito. Yun nasa right. Okay, kapag daw siya ay mas malaki, you have to use it. Diba? Should, less than. Kapag daw itong part sa right ay mas maliit kasi sa nasa left. Pag mas maliit siya, you have to use the left one. Okay? So whichever is lower of the two will be used. So 0.6 Fy. So 0.6 Fy class is our shear yield stress, no? We will later deal with the shear stress, no? But dito pa lang, binigyan lang natin na it is equal to 0.6 Fy. Ito yung 0.6 Fy na yun. Alright? So, 3 GV is our gross area subjected to shear. Gross area plus ng shearing area. So, hindi natin ibabawas yung mga butas ng balls or, butas ng balls. Hindi natin sinasama. KA and V is the net area subjected to shear. Net naman, doon na natin ibabawas yung mga butas. Okay? And then A and T, that's the net area subjected to tension. Net area subjected to tension naman class. That's the tension area, okay, minus the gross area for tension minus the area of the hole. Okay, mga butas. Wait lang. Sorry. Wala na tayo. konti lang yung problems na ibibigay ko kasi yung top activities naman ako. Hindi ko na kayo pagsusolvin sa problem set ng mga, ano ha, timbang. Compute ng U, magaganyan. Okay, we have dealt with those sa ating examples. Diretso na kayo ng analysis, design, mga ganyan. Okay. So, yan. So, the tensile stress is generally considered to be uniform for angles. So, for angles and gusset plates. Okay, and for cope beams with one line of bolts. So, yung cope beam dyan. Okay, that's UBS is equal to 1.0. Ito, single line. Or kapag single line daw, or one line of bolts, we use UBS equal to 1.0. Saan natin gagamitin yung UBS? That is the block shear reduction factor plus UBS. Okay, so should the tensile stress be non-uniform, that is the case with something like this, no? Our shear or block shear reduction factor will be set to 0.5. The purpose of the reduction factor or the block shear reduction factor is to account for the fact that stress distribution may not be uniform on the tensile plane for some connections. Example 7. If we have an A572 grade 50, that's FU is equal to 65 KSI. A572 is 50 KSI to MPa. Kakalimutan ko yung conversion. Nasa module 1 nyo lang yan, no? Ako, sinesearch ko na lang kapag hindi ko alam yung MPa equivalent. 50 KSI to MPa. That's 345. So, A572, that's Fy of 345 and 65 KSI Fu is ayaw niya. 65,000. Yan. But 65 KSI. Yan lang naman yung tatlong yan plus ang lagi natin ginagamit. A36, A992, and A572. 65 KSI is 448. Okay. So, tension member, lagay ko na lang. A572. Fy is equal to 9448 MPa, and Fu is equal to 345. Fu ang 448. Tatawag yun. This is 345. So, the tension members, that is this, yung L na yan, plus, no? That is an A572, grade 50. Ano bang sabi natin for angles? The most common is A36 yata. Subo-subo lang ako ng lugaw habang nagkaklase. So kayo din, baka nagugutom tayo. Determine the LRFD block shear rupture strength and the ASD allowable block shear rupture strength of the member. Also calculate the LRFD design tensile strength and the ASD allowable tensile strength of the member. Okay, So the required are if for block shear strength rupture for LRT, block shear strength, that would be PRN. And ASD allowable block shear rupture, that is equal to R7 all over omega. Now we have to convert the values or the given into equivalent SI unit. Please use your calculators. Punahan ng calculator. Alright. So, okay, again in converting inches to mm, we have to use 25.6. Tama ba? 25.6, 25.4 for the millimeter conversion. So that we have 10 inches to mm is 254 millimeters. Nalilito na rin ako. Is it 25.4 or 25.6?
25.
Okay, 25.4. So it is 254 for the 10-inch length. That's the length of the connection, no? From the end to the center of the last bolt. 254. And this in mm. I will go and compute for the rest. This is 50.8. 101.6. So kapag pinag-add mo yung tatlong yan, this should be equal to 254. $88.9. All right. Now we will not follow this and convert it exactly into or convert it into class. Itong mga given data here for the L6 by 4 by 1/2, but we will use the value in our AAS section database. Okay? Kasi yan, plus ay ano na rin, tawag na ito, rounded na rin yan. Ang ginagawa kasi doon sa ano is sa mga AIS detection database. Dito ka lang pala ipagkita para mahanap. Kita nyo kung saan pinapit. Puro Brexit naman. Ito. Our section, pasensya na kayo guys, may Kung bibidyo okay dito. Kapit bahay. L6/4. You go to the angle section, L6/4, so hindi siya parehas ng legs, no? The other is longer. The other one is shorter. L6/4 by 1/2. Ibig sabihin nun, class, the longer leg is 6 inches. The other leg is 4 inches. Okay, and then the thickness of the angle is 1/2 for the L6/4 by 1/2. Okay, ito siya. Okay, again, you have to go to that column kung saan naka-express yung mga SI units or SI values. Ayun. Okay, pagkatapos na itong equivalent SI labels, yan dito na yung weight, yung area. Okay, so the area is 3,060 square millimeter. So area for L6 is 3,060 square millimeter, and X bar is 0.981. Go to X and Y's. Saan dyan? Okay, let's look at it. That's along the X bar, 0.981 inch. So, eto yan siya. 24.9 mm. Bakit yung 24.9, sir? Ang nakikita natin is yung longer side ang nakakonect. Ganito kasi yan. Okay. So this is the diba? Ito yung longer part. Yung nakapahiga. Okay. And then we have butas dito. For example. Ganyan. That X bar that we are computing is, okay, since it is the lesser one, yung nasa mas maliit na part. Okay, ito siya. It's distance papunta dito sa connection. Or no, dito. Sa end. Okay, yan yung ating 0.981 inch or 24.9 millimeter. Okay? That's the X bar. Alright, what else are we missing here? Wala na ba? Alright, now we can calculate for the block shear rupture nominal strength. Using our formula. Ingay. Naririnig nyo ba masyadong maingay? I hope hindi naman siya nakaka-istorbo masyado na hindi nyo na siya naririnig yung lecture natin. So, 0.6 FUANB, okay, plus UBS, okay, FUANB. Since our connection is just along a single line lang, edi ano lang yan, no? UBS would be equal to point or 1.0. It should be less than or equal to 0.6 Fy. Sorry. Can you guess kung bakit may kasiyahan dito sa amin? Hindi kasama, hindi birthday, may kundi living. Okay, now we have to find the values of the ANB, ANP, and the AGV. Okay, yung tatlong gross areas and net area. First is our gross area for shear, AGV. Okay, AGV is, okay, ito kasi yung ano class, yung direction ng ating load. Ganyan. Okay. Kasi ito yung possible rupture, mahihiwalay yung shaded part na yan. Okay. So, the gross area for shear will be this area, this part. Itong part na to. No? Yan. So, since it is gross, that would be from end to the center of the last bolt. No? Yung full length niyan, you just multiply that by the thickness of the angle. Okay? So that it is equal to what? 254 mm yung full length niyan, no? Wala hanggang doon sa sentro ng ating last connection or last bolt connection. So it is 254 mm multiplied by the thickness. Okay, hindi natin may include yun. What is the thickness? We have to look at the AISC. Okay. Although it should be correct that it is equal to 1/2 pa din. But let's just check. Thickness is 12.7. That's 1/2 inch. Okay. So times 12.7 tayo. No? That 12.7 class is perpendicular to the to what you see. No? Kasi naka 2D lang tayo. 12.7 mm. So what's the answer for the cross area for shear? Then we have the 254 by 12.7 is 3,225.8. Okay. The net area for shear would then be our gross area. Right? Our gross area minus yung mga butas ng ating holes. Okay, but plus, remember, dito sa pinakalas, diba? Dito sa pinakalas, ang computation lang natin ay hanggang doon sa gitna ng ating last bolt. So that if we deduct, since it is net area, okay, we are deducting. Okay, and ano yung dinededuct natin, sir? Yung area ng ating holes. And bibilangin lang natin ilan yung area ng ating holes. That's 1, that's 1, and here it is a half area. So, 2.5 of the area of one hole lang ang imaminus natin. Okay? I hope that's clear. And then what? The bolt diameter is 3/4 inch. What is 3/4 inch plus? That's 19.05 again. We will use 19 mm lang. Alright? So the net shear area would be our gross shear area minus the area of the holes that are subject to shear. Yun plus. For shear. Okay? So our gross area for shear is computed as 3,225.8 minus ilan yung area ng hole natin? Di ba sabi natin kanina? 1, 2, and 0.5. That's 2.5 times what? The area of one hole. That would be equal to ilan? If 19 mm ang ating bolt diameter, what would be our effective hole diameter? Is it plus 4 or plus
23
5?
mm, sir. Plus
23
4,
mm,
sir.
no? That's plus 4. 23 mm multiplied by the thickness of the angle. Ano yung thickness niya ulit, sir? 12.7 mm. Okay, that is our net area for shear. And we have 2495.55. 0.6 na lang. Square millimeter. Pwede nga 2496 na lang eh. Because, pero sige, ganyan na lang. Hindi last, last tens of a decimal. Last one, ANV, AGV, the net area for tension. So net area lang ng tension plus, saan ba yung area that will be subject to tension? Ito yung part na to. This part. If I zoom it in, etong part na to lang. Again, it is from the edge up to the center of the last connection. Okay, etong area lang na ito. Okay, and what is that length? That's 63.5, the full length. But since it is net, we are deducting the area of the hole. Okay? Eh, asan yung area na i-deduct mo, sir? Ito lang naman, plus. Hindi na siya pwedeng i-zoom. Kalahati lang, no? 0.5. Because hanggang doon lang sa gitna ng ating bolt connection. So it is equal to our A and T is equal to yung area na yan, that's 63.5 minus, okay, kalahati ng ating effective bolt hole diameter. Lagay natin the effect diameter of hole is equal to 19 plus 2 plus 2 is equal to 23 mm. So that's 63.5 minus 1/2 of 23.5 kasi kalahati lang yung minus mo na butas. What's 23 divided by 2? 11.5. Okay, that length minus the thickness of the angle na. Okay, ano ba yung thickness natin? That's 1/2 inches or 12.7. Okay, and that's the net area for tension. 660.4. Okay, now we are ready to solve for this. We will copy this. Ang pag-ibig natin ay alright. Okay, now let's compute for the nominal block shear strength. Since our FU and FY is given as 345 and 448, blue na lang. Our Rn now is equal to 0.6 of our FU. FU is 448 MPa multiplied by A and B, which is 2,495.6 plus UBS. Ano bang sabi natin kanina? It is connected in a single line, so it is 1.0 multiplied by FU, which is 448 multiplied by the net tension area, which is 660.4. Ilan ito? Compute plus habang sinusulat ko yung isang condition should be less than or equal to 0.6 of Fy. What you will compute is in kilonewton class, no? Or Newton rather, no? So you have to divide it by 1,000. Anong sagot? Okay. Other answers?
Ganun din, sir.
So what's the answer? Is it 966 or 963?
$963, sir.
Okay, it is 963 because yung unang case, okay, is not less than. Mas mataas siya. So we have to choose what is lesser. Okay, so that Rn is equal to 963. Sorry. Okay, 963.6. Kilonewton. Okay, now we can compute for the block shear strength using our ASB and LRFT. Solving, we have. Okay, now we can compute plus for the block shear strength in LRFD and ASD. Calculator ko, bre. Pwede mo yung isa. Okay, so VRN. This is the block shear design strength. Okay, or the block shear strength in LRFD, 0.75 of our R sub N. Okay, of 963.6. So, nililimit ng ating code that 0.75 lang ang capacity ng ating section. Okay, for block shear in LRFD. Okay, 722.7 kilonewton. Okay, class, ang mangyayari niyan, if this is the block shear strength capacity, 722.7. Dapat, No? If this is our tawag nito, our governing limit state. No? Doon sa ating computation for PU, actually it should be PPN, pero okay lang. Sa computation ng ating PU, usually ang ginagamit lang natin is 1.4D and 1.2D plus 1.6 of live load. Okay? Kung makakompute natin dito, for example, it is 1,000 kilonewton. Okay? Ibig sabihin, class, our section is not enough, okay, to resist yung ating given load. Okay? Because ang capacity niya lang for block shear is 722.7 lang. No? Ganun yun, pagdating sa design natin. So, basically, hindi natin maabot ngayon. On Friday na tayo magde-design. Okay? Letter B is the block shear strength in ASD. And that would be equal to Rn all over our factor of safety. And anong sabi sa NSCP? It is to be a factor of safety of 2. Okay? Because ang rupture class ay tawag na ito. Ano nga yung explanation ng libro? Kalimutan ko na yung term. Hindi confidential. Hindi conservative. 2.00. So half of 963.6 is what to be used as the block shear strength in ASD. Allowable block shear strength. So, kung allowable, sabi niya, we are asked for the ASD. For allowable stress design. Yan, 481.8. Now we go to, anong tinatanong niya? Compute also for the LRFD design tensile strength and the ASD allowable tensile strength. Anong sinasabi niyan, class? We have only checked for the shear or block shear rupture. We have not checked for the cross section yielding and the net section rupture. So, anong gagawin natin? We still have to look for it or solve for it. No? So, letter C or no? We have to put, wait lang, maglinya lang ako para hindi ako nalilito. We have to check for net section yielding and gross section yielding. So first is gross section yielding. Yan. So what do we need? Our formula for section yielding is our P sub n is equal to Fy Ag. We already have Ag that is equal to 3060 and Fy is 345. So direct substitution lang. (3,060) square millimeter and 345 Newton per mm squared. Okay, so you have to multiply or divide it by 1,000. 3.06 by 345. That's 1055.7. Okay, I hope you have the same computation. Then, to check for ASD and LRFD, gross section yielding strength or yield strength. We have VPN. What is V for gross section yielding? Is it 90% or 75%? Kapag gross section class or yielding, we use 90% lang ng 90% or 0.9 for the reduction factor. So 0.9 of 1055.7 is, kung na lang mag-compute. 950.13 kilonewton. And then, for the ASD, we have 1.67. So we have 1055.7 divided by 1.67, which is equivalent to 632.16. And then, we have to check for net section rupture or fracture. So, we have to compute for the net area. That is, saan ka ba magpapas ng cutting plane? Isa lang naman class, no? It is here. Pwede we have to consider cases for the computation of U. Isang butas lang yung i-minus natin, class. Kevin Rafael. Okay, ano bang sabi sa ating code? For it is angle, no? It is an angle connection. Where's the computation for you? Ano yun? 1 less x bar over L and what? It's bolted. It is single line lang. Plates and XSS. HSS. It is case 2. It is not 1.0 because, okay, it is not the whole or tama. It is not the whole cross section that is okay connected by bolt. No? So we have to check. U factor 1 less x bar over L lang. Hindi kasali angle dito eh. Okay. Pasensya na sa mga fourth year ha. Kanina ko lang naalala na ano kayo. Pag-iisahin ko na nga lang kayo sa GC para hindi tayo nagkakaanuhan ng schedule. Kawawa naman mga fourth year. So 632.60 next section rupture, we have to find AN. Okay, that would be equivalent to the gross area minus area of the whole. Okay, since isa lang class, no? Isa lang, hindi tatlo yan, no? Because ang gross area natin, okay, would be that itong part na ito, the angle plus tama. Itong area na ito, buo. That is our gross area and perpendicular to your screen. Okay, yun yung ating section. That's the gross area and it is 3,060. So that is 3,060 minus area of the hole. Okay, isa lang, no? Kasi isa lang dadaanan niya. Isang connection lang yan. Plus, if there is bolt connection on this part, if for example, meron ka pang bolt on this, yung isang leg, no? Na naka-angular. Okay, kung meron ka pang isang line diyan, that is where you are going to use your U is equal to 1.0 kasi yung dalawang part ng or dalawang leg ng iyong angle will be connected. In this case, hindi. So we have to find U to be 1 less x bar over L. So, area ng hole is isa lang, 1 by, ano ngayon, 23 mm by the thickness, 12.7 mm. Okay, and this is our net area. That is 3,060 minus 23 by 12.7. 2,767.9. Please correct me if I'm wrong with my calculations, huh? And the computation for our U, because AE plus, in our formula for net section fracture, our P sub N is equal to your ultimate tensile strength multiplied by your effective net area. And our effective net area is equal to U times AN. So our U then should be calculated as 1 less X bar over L. That's why we have X bar here. Okay, as we have seen in our section database. It is 24.9. So this is equal to 1 less 24.9 divided by the length of the connection. Okay, what's the length of the connection? What do you guys think? Ano bang sabi sa length for connection? It is here. Ayan. That's the length of connection. So it is bolted, so center to center of the first and last connection. Okay? Or end to end. Now going back, ayan. So, etong distance na ito, class, di ba? Saan yun? Ito, this distance. And what is that distance? That's 8 inches or 101.6 times 2. Tama ba? Yes, sir. That's twice of 4 inches or 101.6 mm. Okay, and that is your U. Please compute.
Sir,
Let's
0.88.
use 3 decimal places. Point
0.877.
877. Okay. Pero wag, dalawa lang pala yung ginamit sa book. Gamit tayong isa lang. Dalawa. 0.88 plus. Okay? Now what's next is, silaw man. We can now compute for your AE. And then eventually P sub N for net section. AE then is equal to 0.88 of our net section area, 2767.9, which is equal to. Guys, next week, we will reschedule our schedule. No? Kasi may klase na kami sa NBSU. 2,435.8 square millimeter. So PN is equal to FU, which is 448 megapascal. Newton per square millimeter multiplied by 2435.8 square millimeter. Yan, so that the mm squares are cancelled. So what remains is Newton, but you have to divide it by 1,000 to express it in kilonewton. Answer 1091.2. 24. Please correct me if I'm wrong. Okay, now we can compute for the next section fracture strength in LRFD and ASD. Okay, again, for net section rupture or fracture, we have phi to be 0.75. So 0.75 of 1091.24 is equivalent to 818.43. Pumpansin na natin eh. Ay. All right. If you have guys questions, you are welcome to raise them. You can interrupt. 818.43. For ASD, again for rupture or fracture class, okay, we have to use the maximum factor of safety, which is 2. So that Pn all over omega is equal to 1091.24 divided by 2.0, half. We have 545.62 kilonewton. Okay? Now, we have to choose the answer. Ano bang tinatanong? Calculate the LRFD design tensile strength and the ASD allowable tensile strength. So we have computed so far using 3 limit states: net section rupture, gross section yielding, and block shear strength. So we have to choose from those 3 in LRFD. Okay? Kung ano yung pinakamababa, that would be our governing, okay, design strength or design tensile strength. Saan ba yung dalawa? For gross section yielding, it is 950.13. Net section rupture, it is 818.43. And for block shear strength, it is 722.7. Mali na kaya? Okay. So what do you think is the answer for LRFD design tensile strength? The least of the 3. Siyempre, it is block shear rupture or 722.7. Tama? LRFD design tensile strength. Pn is equal to 481.8. Guys, are you with me?
Yes, sir. Yes,
Oh,
sir.
that's the answer. Now for ASD design tensile strength or allowable design tensile strength. Okay. The list of the 3 limit states: 632, 481, and 545.62. So, tama pa rin, no? So, gandun din yung answer sa libro. It is block shear control. So, for ASD, allowable design tensile strength, Pn all over omega is equal to 481.8 kilonewton. So, yan yung sagot, guys. We'll put yellow. Okay. After that, on Friday, we will have design. No? So, we choose section na kung ano yung available section or what's the most economical section, okay, para ma-resist ang isang given loading. And of course, there are also, kasi wala pa tayo doon sa design for connections at hindi din natin malalaman kung ano yung mga bolts or anong thickness ng weld ang kakailanganin for such design. Okay, we will cover that on the last part of this course. Okay? 722.7 yung ano, kasi LRFD yun. Mali ako sa letter C. It should be 722. Okay, thank you for that. That's my mistake. 722.7. Okay na? Yun. Okay, pasensya na sa fourth year. Idadagdag ko na lang kayo sa GC ng third year para hindi kayo nakakalimutan ko kayo eh. Okay, kung wala ng questions, class, you may now leave our meeting. Thank you so much for listening.
Thank you, sir.
Bye, sir.
Bye.
Bye, sir.
Okay, thank you so much.
Bye, sir.
Okay, bye.